So number 6 then from the 2016 Advanced Higher Mathematics of Mechanics. Here we go, a big word question, 5 marks again. Lots of words here. A remote-controlled aircraft is flown from A to B, accelerates for 10, or just gives you lots and lots of information. And it says sketch a speed time graph for 2 marks, showing clearly, or clearly showing, all the important information. We'll do that first. So here's the graph then. Now it's just a case of put all this information into, what sort of size is this? 10, 20, 60, 10. Right, so it's flown from point A to point B, accelerates for 10 seconds. It's flown from rest, so it starts at 0, and after 10 seconds, it gets up to 15. So that's 15. Accelerates for a further 20 seconds. I think my scale's going to be a wee bit wonky here. Further 20 seconds at a slower rate till it reaches a cruising speed. So a slower rate means it will have a less steep gradient, where that's going to be u. It maintains this speed so that velocity will be horizontal over time for a further, and of course a further 20 seconds means it's taken up to 30. For a further 60 seconds, so we're now up to 90. It then decelerates for 10 seconds to a complete stop. So that means we're now up to 100 seconds. That's about it, as long as that line looks horizontal for the first part. The only other thing you might want to do is put your wee dotted lines in, just to show what these different parts are. And of course, like a dotted line there implies that's horizontal. So there's 2 marks. And so part B. If the distance travelled from A to B is 1.725 kilometres, what's the value of u, this cruising speed, for another 2 marks? Well, the total area under this graph will equal the distance travelled. So you could write area equals, or you could simply say the integral of v dt should come to 1725. Remember, that has to go into metres. But I'm not going to do an integration because I've got 4 distinct shapes here. So I've got triangle, trapezium, rectangle, triangle. Triangle, a half of base times height, half of 10 times 15. Trapezium, average base, the base being the parallel sides, so it's a half of, now that one is 15 and that one is u, half of 15 plus u times the height, the distance between them is 20. Rectangle, base times height, that's 60 times u. And triangle again, a half of the base is 10 and the height again is u. That should come to 1725. Now you just got to work it all out. So that part there will be 75 plus half of 20 is 10, so it's 150 plus 10u plus 60u plus 5u equals 1725. Tidy up the u's and you've got 75u equals, now quite nicely that's 225, so that just leaves 1500. 75 is a half of that, so u equals 20 metres per second. Now that was worth 2 marks. There was 1 for the answer, and there was 1 for this adding up the areas and equating it. So there's 4 marks, but there's 1 more mark because there's a part 2. State one assumption you've made about the path of the aircraft. Well, you're assuming that the path of the aircraft has been, as it's travelled, this linear, if you like. But of course it's not linear because it's going to be up in the air and down again. You're assuming that by linear you mean it's in a plane. You're assuming that the path of the airplane, the path lies in a vertical plane. Oh, plane. And that's the 5th mark.